For number 8, we were missing the totals, so I went ahead and totaled everything up for you. The way that you can find the totals yourself is to just add across and write a total, add across, write a total, add down, write a total, and then total your totals and make sure that everything is correct. If you total this way and you get 944, then you total down and you get 930, you've made an error somewhere. So you'll need to double check. So after writing in all the totals, it asks, what is the probability that a randomly selected person does not have a job and is less than 18 years old? So a person that doesn't have a job and is less than 18, if they do not have a job and are less than 18, that's going to be right here. That's the intersection, which is 245 out of everybody, which is 944. And is the intersection. This looks like an N, so it looks like and union is or. And when I do 245 out of 944, I will get 245 out of 944. It gives me 0.259, which is 0.26 when rounded to the 100th place. For B, what is the probability that a randomly selected person is less than 18 years old, given that the person has a job? If we're given that the person has a job, we're only looking at the people that have a job. So people that have a job is 607. So out of those 607, what is the probability that a randomly selected person is less than 18 years old? So if we're only looking at people that have a job, out of those, 20 are less than 18. And if we do 20 out of 607, we get 0.03. It ends up being 0.032, and that 2 will keep this 3 the same. What is the probability that a randomly selected person is greater than or equal to 18 years old, given that the person has a job? So it's the same as this one. If we're given that the person has a job, we're only looking at people that have a job. So it's going to be 607. And out of those people, how many were over or equal to the age of 18? So out of the people that had a job, 18 or greater is 587, which is going to be 0.967, which will round up to 0.97. It then asks, is a person who has a job more likely to be less than 18 years old or greater than or equal to 18 years old? Keep in mind, greater than or equal to 18 is one piece, and less than 18 is another piece. And they're asking why. If we look at the probability of people who are less than 18 that have jobs, that's only going to be, out of the people that have jobs, only 0.03. The probability of them being 18 years old or less is 0.03, or a 3% chance of them being under 18. For the people who have a job for the people who have a job, 0.97 or 97% of them are over the age of 18. So we would say it would be more likely that the person is more likely to be greater than or equal to 18. And again, this is because the probability of someone being 18 or older, if they have a job, is 0.97 compared to 0.93. This probability is much higher than this one. For part E, are having a job and being 18 or greater independent events? Justify your answer by showing all your work. Again, if we're trying to test independence, we'll say the probability of the intersection must be equal to the probability when you multiply them together. So the intersection of A and B, A being having a job, and B being 18 or greater. That's going to be 587 out of 944. Again, that's going to be the intersection, and we're going to see if that's equal to the probability of A, which is, again, having a job. So having a job is 607 out of 944, and the probability of B, which is being 18 or greater. 18 or greater has 679 out of 944. When we multiply those all together, we get 587 divided by 944 will be 0.62. Let me scoot this down a little bit. 0.6218, and we're going to see if that is equal to 607 divided by 944, and we're going to multiply that by 679 divided by 944. And we end up getting 0.46, and I can stop there and see that these numbers are not the same. They are not equal, so therefore, no. Not independent. And you can justify that with your work and by showing that they are not going to be equal.